Okay, so the equation that I have is x squared plus 3x plus k minus 1 equals to 0. Notice that in this case, this is B and this is C. Yeah. For the first part, we'll have two roots, so the two solutions to the equation are equal. So we'll have alpha and alpha. And if you remember from the sum and the products of roots, the B is the sum of the roots. So it has to equal to alpha plus alpha, which means that 3 equals to 2 alpha and alpha equals 1.5. So 1.5 is the two equal roots for this equation. And C is the product of roots. So alpha times alpha, because the product of two roots, obviously. So alpha times alpha, which means that k minus 1, remember k minus 1 is the C here, equals to 1.5 times 1.5, so k minus 1 equals to 2.25, and k equals to 3.25. Now, B, it's asking for one root, that is minus 3. So there's only one root. In this case, it's quite straightforward. We can just substitute this root into the original equation and see which k satisfy it. So we can have minus 3 squared plus 3 minus 3 plus k minus 1 equals to 0. And in this case, it's 9 minus 9 plus k minus 1 equals to 0, k minus 1 equals to 0, and k equals to 1. Now, the third part, C, it's asking for one root that doubles the other. So we have alpha for the first root, and the second root, 2 alpha, the second one doubling the first one. Once again, using the sum and the products of the roots, B equals to alpha plus 2 alpha, which means 3 equals to 3 alpha, and in this case, obviously, alpha equals to 1. Now, for the products of the roots, C equals to alpha times 2 alpha, which in this case, it's k minus 1 equals to 1 times 2 times 1. So k equals to 2 plus 1, k equals to 3. So in this case, k equals to 3. Now, next case, consecutive roots. So first one will have alpha, and the second root will be alpha plus 1. So this one is consecutive of this one. Now, once again, we use the products and sum of roots. B equals to alpha plus 1. So 3 equals to 2 alpha plus 1. And once again, alpha equals to 1. And the second part, C, equals to alpha times alpha plus 1. And k minus 1 equals to 1 times 1 plus 1. K minus 1 equals to 2. And k once again equals to 3. Obviously, you can see that the results are the same for C and D. That's because the first root, alpha will be 1. Here, alpha will be 1. And in this case, if alpha is 1, then 2 alpha will be 2. And in this case, alpha is 1, alpha plus 1 is 2. Because in this case, 2 is double 1, but 2 is also the number after 1. So it's both double and it's consecutive. Now, problem E. It's looking for reciprocal roots, which means that there are two roots, alpha and 1 over alpha. So reciprocal means that two numbers, their product is 1. In this case, we just have to look for C equals to 1, and so, which means k minus 1 equals to 1 and k equals to 2. And that's it. I hope this answers your question.